Poly, which means what?
Many gods.
It just means many. Polytheism means many gods, but poly means just many. And then if you turn the page to the first lesson, it says multiplying monomials. So what does monos mean? One. So polynomials is the general category of what we're dealing with this chapter, but this lesson we're dealing with one monomial. And we're going to talk about what is a monomial. That's a good question to ask before you get into monomials. Like, what in the world is a monomial? Does anyone remember what a monomial is? Can anyone read what a monomial is?
One meal.
Meal. Monomial. So we're going to call a monomial a number, a variable, or a product of a number and one or more variables, which sounds like a lot and probably a mouthful, but it's really not that bad, because in the definition, I hope you can see that we have talked about this before, although maybe not the word monomial this year. We have talked about a number. So a number by itself is a monomial. So have we talked about monomials? Of course we have. Have we talked about variables? Yes, a variable by itself is a monomial. So we've dealt with that. And then this last one's kind of confusing. But what does the word product refer to? Multiplication. And it says multiplication of a number and one or more variables. So if you have 5 times x, is that a monomial? Yeah, because it's a product of a number and x, 5x. So have we dealt with monomials? In fact, you know your last test? All I wrote on that whole page, on all those pages, were a bunch of monomials. Now we're going to get into multiplying them. But just to let you know, we've dealt with it, so don't be too scared about what a monomial is. You've already dealt with that. Okay, there's a special, yes sir.
What the product of a number and one or more variables would be a polynomial? Because it's more than
Okay.
one monomial?
That's a good thought, like poly, many, so more than one, many. It's actually, the reason it's a monomial is because there's no addition going on. When you have 5x plus y, so yeah, that's a polynomial. Two monomials together. Yep.
If you add or subtract.
It changes to a polynomial. Yes, very good. So today we're just dealing with one monomial at a time, which is nice. Okay, there is a special type. It is called a constant. And I have referred to this occasionally in class, a constant. It's a special type of monomial. How special is it? It is a monomial that is a real number. What? So constant is a real number. That's it. It's a real number. So a real number, that includes all your whole numbers, your integers, and what other types of numbers? Fractions and decimals. So have we dealt with constants? Yes. Do you guys know that there's a difference between a constant and a variable? Does anyone know what the difference is? One is?
A variable or a letter.
Okay, one can be a letter. One is unknown or can change. And one of them is known and it stays the same. So does that make sense that a constant does not change? So let's look at the bottom page 496. Let me show you what these look like. Okay, a monomial. Look at that little chart in purple, the very bottom one that has 2 columns, not the one above it that's really complicated. All right, 12 is considered a monomial. Why is 12 a monomial? Because it's a number. Why is Q a monomial? It is a variable. Why? Oh, why is 4x cubed, though, a monomial?
Because it's more than one number or variable.
There's a little bit more to that, yes?
Because it's a product of
Product.
a number and one or more variables.
Yeah, it's a multiplication problem with a number and one or more variables. So what's the number in that monomial? 4. And how many variables are being multiplied technically? 3 of them, like x times x times x. So 4 times x times x times x is a monomial. What about 11ab? Is that a monomial? Okay, 11 is being multiplied by what two variables? A and b. That's a monomial. Oh, 1/3 xy to the 12th. That cannot be a monomial. Or is it? Okay, 1/3 though, that is not a... Wait, is it a number? Is 1/3 a number? Yes. And is it being multiplied by one or more variables? Of course it is. By the way, let me see if you guys can get this here on that last monomial. How many variables are being multiplied on 1/3 x, y, z to the 12th? How many variables are being multiplied?
36.
Lower, way lower. How many x's are there? How many y's? How many 12s? Or how many z's? So how many total? 14 variables. You have x times y times z 12 times. 14 variables being multiplied. Is that more variables, by the way? So that's a monomial. Look at the other column. Why is a plus b not a monomial? Brian? Why is a plus b not a monomial?
Because it's two monomials.
There you go. It's actually a binomial. It's two monomials, so we're not going to talk about that. What about a over b? Huh? Yes, John? It's what?
No.
Why not? It's,
It would just be, it doesn't have any actual.
there's one thing that's not happening there. Autumn? Yeah, what is it being? A over b. Divided, good. What about 5 minus 7d? Ha! There's no addition going there. Or is there? Yeah. Is 5 minus 7d addition? Yes, it's 5 plus negative 7d. Good. And the other ones we'll encounter those later. Okay, we're good with those terms. Now I'm going to use them in actual multiplying. Yep. What a great example, counter example we call it. We'll talk about that. Why is that not? Because isn't it multiplication, kind of? Good question. Let's look at a property of powers. And I was telling the other class, as I was prepping up this lesson, there are 4 properties that we look at in this lesson, but I'm like, that's a little overload. Because they're very similar, I'm going to really look at two main ones. The first one is called the product of powers. Okay, what does product refer to? Multiplication. But what does power refer to? Any number that has an exponent. Good, an exponent. So we're just talking about when you're multiplying monomials that have exponents. Okay, let's go through an example here. 2 to the 3rd times 2 to the 5th. Okay, there is a way to figure out what the value of that is. And there are actually multiple ways. I'm going to go through the long way. Okay, 2 to the 3rd. What multiplication problem is that? How can you make 2 to the 3rd into a multiplication problem? Lucy? 2 times 2 times 2. Yes. So how many times is 2 used as a factor in this expression? 3 times. What about 2 to the 5th? What's that as a multiplication problem? No, Lucy knows. All right, Nate? Okay, can I ask you a question? What's easier to write? 2 times 2 times 2 or 2 to the 3rd? What's easier to write? 2 to the 3rd. What's easier to write? Maybe if you're like, nah, they're the same. What about this one? 2 times 2 times 2 times 2 times 2 or 2 to the 5th? Which one? 2 to the 5th. So powers is actually a shorthand way of repeated multiplication. All right, how many times is 2 being used as a factor altogether? How many times? 8 times. So I can say that 2 to the third times 2 to the fifth equals 2 to the eighth. Was there an easier way to do that? It's got to be an easier way. Or you just write them all out. Lily, what do you think? Add what together?
2 times 2 to the third plus 2 to the fifth.
Very close. Okay. These are being multiplied, right? These two are being multiplied. You want to correct it? Add the exponents. Are these two expressions being multiplied? Yes. Do they have the same base? Yes. What do you do with those exponents? Add them. What's 3 plus 5? 8. So do you have to write it out through multiplication? Nope. You just add those exponents, okay? And this is the way that your book puts it in algebraic form. A to the mth power, which is hard to say, times a to the nth power, which is a little easier to say, equals a to the m plus n. Huh? Okay, let's write that down real quick. They just pick them. They just pick letters. You could have put X and Y, C and D, but pick M and N. Okay, if you're multiplying two monomials with the same base, what do you do with those exponents? What do you do with the exponents? You add them. Okay, so that's what we're doing. Let's look at example 1a. See how we work this one out. Example 1a. 3a to the sixth times a to the eighth. Okay, this is kind of complicated. There's a lot going on here. Once you write that down, you can look up on the board so we can kind of see what's happening in these expressions. Okay, what's going on between 3 and a to the sixth? What operation? Multiplication. What's going on between 3a to the sixth and a to the eighth? Multiplication. Is everything just being multiplied? Is everything just being multiplied? The answer is yes. Do you have to multiply in a certain order when you have a string of multiplication? No. You can do it in any order you want. Why don't I multiply these two together first? So does anyone know what a to the sixth times a to the eighth is? A to the 14th. How in the world? Wait. Oh, isn't a used as a factor 6 times here, and a is used as a factor 8 times? What's 6 plus 8? 14. And what happens to that 3? It doesn't just go away. It's still times 3. All right. Can I ask you a question here? Which one's simpler? 3a to the 14th or the original problem? The original problem is simpler? Really? I don't. I bet this. The reason is, you know why this is simpler? I'll give you 2 reasons. How many parentheses are in the bottom? None. Got done with that. And how many times is a used in the bottom?
1.
How many is it used up top? It's simpler down here. No parentheses. A is only used once. Simple to use. Let's look at B then. This is funny because I mentioned this in the last class. How many thought this was pretty basic, pretty straightforward? Okay, I'm going to up the intensity dramatically. But I think, you know what? I'm changing my mind. I think the Lord's giving us some insight here. Don't do that. Go to page 499. We'll go back to B in just a moment. 499. And let's just work out number 9. Let's just do that. Get practice with this. Number 9. Okay. A to the 4th times a to the 7th times a. Okay. It's not simple because what do I have in that expression? Parentheses, and how many times is a used? 3 times. That's too complicated. Is there a way I can combine those together? Well, let me see. What's going on between a to the 4th, a to the 7th, and a? What operation? Multiplication. So can I combine them into one? Yep. What do I get? Maggie? Let's see. What's 4 plus 7 plus That's okay. That's all right. Just want to make sure we all got it. Yes, ma'am?
Wouldn't it be 3a to the 12th?
Good question. This is a question here. Why aren't we getting like a 3 since there are 3 A's? Okay, if I had A plus A plus A, doesn't that give me 3A? But am I adding any of these? Like, am I adding A to the 4th plus A to the 7th plus A to... No, so it's not 3A, it's just A to the 12th. There's only multiplication going on here, no addition with the bases. Okay, A to the 12th is your answer here. You guys good with that? How many of you got that? Okay, it's okay if you sort of did. How did you get that 1? I just wrote that in. Can you just do that? Just write 1s wherever you want? No. How many times is A used as a factor? It's used once, so you just put a 1 there, and it counts. 4 plus 7 plus 1, 12. Okay, let's do another one here, just to get practice, because it does get tougher. Number 10. Number 10. And I'll work this one out with you guys, because it's not always easy to digest when you first look at it. Okay, I'm looking at this thing, and not simple, I know that. Can I move around the factors? Am I allowed to just move them around? And the answer is, can I move them around?
Sure.
Yes, because what property says I can move around anything when they're being multiplied? Commutative property. So I'm going to multiply x and x squared. Does anyone know what x times x squared is?
3 or x squared.
X to the third, or x cubed. Yep, because 1 plus 2 is 3. What's y to the 4th times y to the 3rd? Y to the 7th. Do I have any more parentheses? Do I have any multiples of a variable? No, I just got 1x to the 3rd, 1y to the 7th. Okay, guys good on that? Yes, sir.
Why isn't it xy to the 4th?
XY. Oh, good question. This is where it's important here. Why isn't xy to the 4th power? What you're saying is, why isn't it xy to the 4th power? That's xy to the 4th power, which doesn't look a little bit different from that one. We're going to deal with both of these today. So good question, because we're going to deal with this as we go. Okay, let's go back to example B. Turn back a page, example 1B. Oh my, what happened here? 1B. All right, it takes me a while just to write it down. Just want to make sure I wrote that right. That would be a shame. Okay, yes, ma'am? X cubed, y to the 7th. Okay, I'm looking at this and thinking to myself, that's a lot, right? Is it simple? Absolutely not. A lot of parentheses, and x's and y's all over the place. Can I move them around? Okay, but don't I have these numbers here? I haven't had those very much in these problems, bless you. Can I multiply those numbers first? Yes, I can. So I'm going to show you my multiplication of these three numbers, and you can do it just the way it's written, or you can rewrite it. X times negative 3 times 3/8. By the way, my answer is positive or negative? Go.
Negative.
Has to be negative. Automatically. What's up? Positive times a negative? Negative times a positive is still negative. All right, I get negative something. But you're like, oh man, we got to do 8 times 3, and then times 3 again, then divide by 8. Or can you do something before you multiply? Is there anything I can not cross multiply, but cancel? Isn't this over 1 and that's over 1? So can I cancel these guys? Can I cancel those? No, they're both in the numerator. Do not do that. One's in the numerator, one's in the denominator. That's okay. So what's 3 times 3?
9.
Oh, okay.
Wait, I have a question.
Yes.
Why would you
Okay, what's going on between 8 and y cubed? Negative 3 and x squared and y squared. So can't I rearrange everything? So can I just bring that negative 3 next to the 8 and multiply those first? And bring that 3/8, multiply those first. I don't have to keep them together because what's going on between them? Multiply it. So now I can multiply all the x's. What's x squared times x? X cubed, or x to the third, right? Because I have 2 x's here being multiplied and 1 there, so 3 of them total. Y to the 3 plus 2 plus 4. This is my simplification of it. How many of you got that? Okay, good. This is tough. It's not easy. I'm not saying, oh, you didn't get it. How could you? It's hard. Yes, ma'am?
If you accidentally wrote it y to the 9th times negative 9x.
Okay.
Can you not do that since there's parentheses? It looks like you're
Great. Actually, you answered your own question, which was good. If you put like y to the 9th times negative 9, don't you have parentheses? So you want to drop those out. All right, this is how you write your answers. You always write the numerical part first, then the variables. And you technically could have written this negative 9 y to the 9th x cubed. That's okay, but we tend to write it in alphabetical order. Remember the alphabet? X and then y. It's what we tend to do. Make it easier on ourselves. Okay, questions on that one? That was tough. That's not easy, but we're going to keep practicing. Okay. Let's look at another example here and see if we can figure this out. That is not simplified. Do you guys understand why it's not simplified? Why is it not simple? There's one, maybe 2 reasons, depending on how you look at it. Lucy? The parentheses. But I don't just drop them out and just say it's good. I want somebody to tell me what this means using multiplication. So can I write this as a multiplication problem? And who can tell it for me? Who can tell me what that is? Jack, you want to try?
8 times 8 times 8 to the, or in this all to the 5th power.
Okay, so you can write it 8 times 8 times 8 all to the 5th power, right? I agree with that. It can actually be written out even further than that, which is, it does take too long. Thankfully, I'll do it. Yep.
So you would do 8 times 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 8.
Wait, how many times? Can you start all over? No. How about this? Can I rewrite it like this? Ready? Save us all time. Can I write it 8 to the 3rd times 8 to the 3rd times 8 to the 3rd times 8 to the 3rd, and to save us all some breath, 8 to the 3rd. Is that allowed? I mean, is that the same thing? It's 8 times 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 8. That is harder to say than you think. Yeah, and so now we look at this and we're like, man, that's a complicated expression. What does that equal? And don't tell me how to do it yet. Just tell me what it equals, John. Oh, 8 to the 15th. Oh, yeah, I agree. That is correct. Because aren't these all being multiplied, right? Aren't these all being multiplied? So what do you do with those exponents? You're adding them. How many? What's 3 plus 3 plus 3 plus 3 plus 3? Okay, but is there an easier way to do this? Like, do you have, I mean, oh, man, that's a lot of work. Or is there anything you can do to make this simpler, easier, healthier? Maggie.
I have a question.
Oh, go ahead.
Why would you? Okay, well, doesn't the 5 have a 1 in front of it, like as the?
This right here? No, just think of it as the number 5. Like if I put a 1 in front of it, it would make it 15.
But like she meant like 1 to the 5th power.
Oh, I see. Like, does it have a base? No. The base is, that's the base. 8 to the 3rd is the base raised to the 5th power. It's a complicated expression, but that's what it is. But that's why, how many times did I multiply 8 to the 3rd? How many times? I did it 5 times. instead of doing all this work, what can I do with those two numbers? Just multiply them. 8 to the third raised to the fifth power is just 8 to the 15th. Okay, that's as simple as you can get. So, say that again?
It can be simpler.
Yes, you can find what 8 times 8 times 8 times 8 times 8. By the way, is that a big or little number? It's huge. I'm talking huge, like big. Like big, your calculator is going to say error, can't fit it. That's a huge number. You don't have to find it. Sorry?
You should multiply it.
No. Okay, but anyway, let's see if you guys can get this one. Can you guys do this one? Make it simpler. So you can go the long route, or you can just say this, Mr. A. Y to the Jackson. 21st. That's it. Okay. When any expression is being raised to a power, if that has an exponent, just multiply them, and you get your 21st. Okay? You guys okay with that one? Let me give you, it's a slightly tougher one, but I think you can handle it. A to the m power raised to the n power. This is using algebra. Like for any instance, what would you get for this simplified expression? There are no numbers there. Carson.
A to the N power.
Very good. A to the mn. Guys okay with that? All right, let's go to another example here. You guys are doing well, by the way. You guys are really doing well. AB to the fourth power. See if you can figure that out. Just try it. If you get it, great. If you don't get it, it's okay. We'll go over it. AB to the fourth power. So, Brian, remember you asked that question? This is AB, all of it to the fourth power. So what does it actually mean without those parentheses? I don't know. Help me out. Jenna? What? That? Really? Okay. The reason I can say AB to the fourth power is A to the fourth, B to the fourth. Okay, listen carefully. Look up here so you guys can get this. Isn't AB the base and 4 is the exponent? The base is multiplied how many times? 4 times. So A times A times A times A is A to the, and B times B times B times B is B to the. So, is there an easier way to do this? Of course there is.
AB to the 8th.
What's AB to the 8th?
It's AB to
Oh, yeah, this is A to the fourth, B to the fourth. So a lot of talking, and that distracts me and other students, I think. Okay, is there an exponent for A in this expression? It's 1. Is there an exponent for B in this expression? It's also 1. So what really did you do with those two numbers? You multiply those two and you get 4. You multiply those two and you get 4. That's how you figured it out. Okay? All right, let me give you another one here. 5PQ to the fifth power. Now, you can try 5 times 5 times 5 times 5 times 5. Don't do it. It's big. Or you could just write 5 to the fifth power. That's okay. You're like, why would you write 5 to the fifth power? Well, hopefully you understand why. Yes, ma'am? Do you know what the answer is? Don't tell me what it is yet. I don't want to know what it is. I will call on this side of the room, one of you, who looks ready. Yeah, good acting. Abby. Very nice. That is correct. Good job. What exponent does 5 have here? P, Q, 5. So 1 times 5, 1 times 5, 1 times 5. That's your symbol. You could tell me what 5 times 5. Don't do that. It's too much work. Not necessary. All right, let's see if you guys can get this next one here. A, B to the M power. AB to the n power. What would that be? Or what would that A be? What would that be? What would that A? No, what would that A be? All these letters. Too many. Nate. Good. Very nicely done. That's it. That's it. Good. And good use of the TH sound. Mth power and mth power. You guys okay with this? Because it's gonna get tougher here. One more degree tougher. One more. That's it. Actually, how about this? Go back to 499 and do number 12. Number 12 there. That'll give you good practice on what we were just doing. And if you can find the exponent, if you can find the value of a number to some power, like if you can do that quickly, do it. If you can't, don't do it. Like 5 to the 5th, I can't do that in my head or quickly. But can I do 2 to the 2nd? All right.
Good job, Walker.
Jackson, I need to see you after class. All right. Can I get someone to volunteer from this side again? Because you guys did so well, Abby. Someone who looks at me. Thank you, Brian. What do you have?
4a to the 4th times b to the 2nd.
Oh my, good job. That's it. Okay. Yes, remember what I said? Did you guys hear what I said with that?
No.
If you can find out what 2 to the 2nd is, very quickly write it out. So 2 to the 2nd is 4. So that's what I wanted.
No.
Yeah, don't mess with this chair. Any questions on this part right here? Any questions on this part right here? Okay. Last thing, the most difficult one. I think you can handle it. You guys are doing very well. Is if you look at, let me give you this one. See if you can get it. Let's see. Okay, ready, guys? If you can get this, we're very well set. A to the m power, b to the n power, raised to the p power. What would that be? So a to the mth times b to the n. Maybe I should make that bigger. Raised to the p power is what? Not yet. Middle section. Whoever looks at me. Whoever looks at their paper. Simon says, look at your paper. Okay, Lily. What'd you get here?
I got A to the NP power and B to the NP power.
That's it. Yeah. If you want to avoid the TH sound, just say A to the MP power or B to the NP power. You guys get that? How many of you got this, by the way? This is good. Okay. Ultimate question time. Example 3. Example 3. 2a to the 4th b raised to the 3rd power, negative 2b to the 3rd raised to the 2nd power. Oh. Is it simple? No. There are not only parentheses and multiple variables, but there's also brackets. The braces are the more curvy outside extension of this, but here we have parentheses and brackets and parentheses and multiple times b is used. Okay, we got to take it in a certain order. And you're thinking, what? There's an order? Do you guys remember there's an order of operations? What do you deal with first? Parentheses. So I have to deal with what's inside here and what's inside there. Can I make anything in here simpler? Just look at the inside. Can I make anything simpler? No. It's as simple as it gets in there. Can I look in here and make anything in there simpler? No, we're done with that, the parentheses. But don't we have these brackets? Can I make anything in here simpler? So can I get rid of those parentheses within the brackets is what I'm asking. Yes. Can anyone tell me what's going on with these values? And this is tough. This is very tough. That's why I gave it to you, so you're ready for it. Okay, Claire?
I forgot.
Yeah. Oh, so close. What's negative 2 to the third power? Negative 2 times negative 2 times negative 2 is negative 8. So you're going to get there, Claire. Negative 8, b to the, good, b to the third power. That's what you get when you simplify this set inside here. Don't I still have that 2 there? Don't just forget that, by the way. Can I get this simplified? Can I make this simplified right here? Oh, by the way, parentheses. Can I make anything simpler here? Nope. Can I make anything simpler in here? Nope. Next step. Exponents. Can I get rid of these? I can. How do I get rid of this guy right here?
You multiply everything too.
Can anyone tell me? How do you make this simpler right here? 2 to the third power. Very good. That's it. That's that first set right here. And I'm going to bring it down one more because then you're going to have to simplify this part right here. Oh, man. How do you do that? I can't do that. What's negative 8 to the second power? What's negative 8 times negative 8? Right here. Negative 8 to the second power. Negative 2 to the third power is negative 2 times negative 2 times negative 2, which is negative 8. So negative 8 to the second power is negative 8 times negative 8, which is positive 64. Oh, my. 64 positive. What about b to the third and the second power out there? B to the, say it. I hear someone's kind of ready to say it. Sixth. Yeah, it's b to the sixth. 3 times 2 is 6. Oh, there's no way to make that simpler. Does anyone know what 2 to the second is? Can you make that easy? 2 to the third is 8. Good. I'm glad you guys got that one. Can I make this simpler?
Yeah, no.
What's 8 times 64? It's 512. Save yourself some time. A to the 12th. There's no more A's. There's just one A there. B to the 9th. Whew. That's a lot.
Yeah, I forgot to add things.
B to the 3rd times B to the 6th. You add those two together to get 9. Okay. If you're looking at your, look on page 499. I'm just trying to help you right now. Don't get overwhelmed. Mr. I can't do this. Look at page 499. You're doing 17 to 35 odd. How many problems are like that?
All of them.
Wait, what did we do? What is
17 to 35 odd. How many are like that one?
All of them.
One. Okay, if you want to say 0, I actually agree. One of them is kind of like that, but none of them have this. None of them have the bracket. Do you guys understand that? Is it really that bad? No. But look at number 35. This one's a nice one that I'll give to you. Look at number 35. There's something different about that problem and all the other problems we've done today. Does anyone know what it is? There is subtraction. So I'm giving it to you. See how you guys do on it. If you get the right answer, I need to see the work. So don't just, I got it. Look, wow, I got it. How'd you get it? Let me get back to you on that one. So please make sure you work it out. Yeah. I think I want to go through one more example then. One more practice problem. Number 14 on 499, because this one's good for a couple of them. And then I will be done. 2x squared to the second power and 1/2 y squared to the second power. Oh no. Okay. So order of operations, parentheses. Is there anything that makes simpler inside here? Anything that makes simpler here? No. Anything simpler here? No. Next step, exponents. Can I get rid of this exponent in this expression? And stay with me, I'll tell you. I'll give you some good news, I'll give you some bad news, I'll give you some medium news, but stay with me. What's 2 to the second?
4.
Yeah, and actually, thank you. It's just 4. We're just going to call it 4. What's x squared to the second power? X to the 4th. Very nice. And these are being multiplied. What is 1/2 to the second power? Be super careful. 1/4. Because what's 1/2 times 1/2? 1/4. Not 1. That's added. Y to the 4th. You're like, can I make that simpler?
Cross it out.
What out?
4.
Aren't these two being multiplied? Don't those cancel each other out? What do I get? X to the Y to the... Okay. I'll write your homework on the board. Oh, you don't want to hear the news? It's good. It's good. Yeah, it's due Monday. It's, let me give it to you. Hold on. There really is some other news. 17 to 37. Oh, wow. 17 to 35 odd. And then 45 to 47. So just a few more problems. That's page 499 to 500. So you can write that down. So let me circle that for you. Okay, tomorrow we're going to have like partial class periods. And we're going to do the Math Olympics. Dun, dun, dun. Which means you don't have to prepare for that. Like, Mr. A, what should I study? I'll say study all of math. I can't prepare you for that. That's tomorrow and maybe a little bit on Monday, but that will be tomorrow. Thank you, guys.